Hey there! In this video, we'll talk about DTOs or Data Transfer Objects with the ABP Framework. So, a DTO or a Data Transfer Object is a simple object that is used to transfer data between the application and the presentation layers, or other types of clients. If you've watched the domain service video, you might remember that we aimed to isolate our domain entities and only access them via the manager classes that we would create inside the domain layer and then inject in the application layer. Does that mean that application services never work directly with the entities? No, they sure can, of course. In fact, we'll only create domain services whenever we want to implement a core business logic that cannot be implemented in the aggregate root or entity classes. And that's typically what's happening. An application service is optionally called from the presentation layer with a DTO as a parameter. It uses the domain objects that we've got from the domain layer to perform some specific business logic and optionally returns a DTO back to the presentation layer. And therefore, the presentation layer is completely isolated from the domain layer. So why do we need DTOs? There are several reasons to use DTOs and a lot of problems that can be solved when we use them. Reasons such as the abstraction of the domain layer, data hiding, serialization, and lazy load problems. And if we explain each of these reasons, the video is going to be too long, so you can read more about them in the documentation. A DTO is a simple class that has no dependency and you can design it however you want. ABP does not force you to use DTOs. However, using DTOs is strongly suggested as a best practice. DTO classes will be placed in the application contracts layer, and when we create the application service methods, the method itself will pass the DTO as a parameter. ABP introduces some interfaces to determine the conventions for naming standard properties in base classes, so that you don't repeat yourself while declaring common properties. They are not required, none of them is required, but using them simplifies and standardizes your application code. First of them is the entity DTO with the primary key. It's a very simple class that only defines an ID property, and you can derive it for the DTOs that match your entity. And you can also implement its interface. And next up is the audited DTOs. If your entity inherits from audited entity classes, or implements auditing interfaces, you can use the following base classes to create your DTOs. From the creation audited entity all the way to the full audited entity with the user. And you can check out each of these classes so you can find out what they offer. Next up is the extensible DTOs. If you wanted to use the object extension system that allows you to add extra properties to an existing object without modifying the related class of your DTO, then you can derive one of the following DTO classes. They all implement the iHasExtraProperties interface, but each has its auditing and creation cases. And next up we've got the paged and sorted list results. It's more common to request a paged list from the server and return a paged list to the client. And ABP defines a few interfaces and classes to standardize it. As for the input request types, we've got the limited result request DTO, paged result request DTO, and paged and sorted result request DTO. The limited result request DTO has a default max result count, which is 10, and it can be changed. However, if the client sends more than 1000 requests, it produces a validation error to protect the server from the abuse of the service. And you can change that value by setting the max result count static property. And as for the output response types, we've got the list result DTO and the paged result DTO. The paged result DTO derives the list result DTO, so it's the same, but it adds the paging feature. And for the best practices, you're free to design your own DTO classes. However, there are some best practices and suggestions that you may want to follow. First of all, DTOs should be well serializable since they are generally serialized and deserialized to JSON or other formats. So it is suggested to have an empty public constructor if you have another constructor with parameters. DTOs should not contain any business logic, except some formal validation code. Do not inherit DDOs from entities and do not reference to entities. We need to keep the layers separate. If you use an auto object-to-object mapping library like AutoMapper, for example, you should enable the mapping configuration validation to prevent potential bugs. As for the best practices for the input DDOs, only define the properties that are needed for the use case. Do not include properties that are not used for the use case. It could get very confusing. Don't reuse input DDOs among different application service methods. If the application service method only creates a product, then make a createProduct DDO class. If the application service method only updates the product, then make an updateProduct DDO class. Do not make a product DDO class that has the properties of both the create and update. Different use cases will need and use different properties of the DDO, which results in some properties being used in some cases and not used in other cases. And that makes it harder to understand and causes potential bugs in the future. Only implement formal validation inside the DDO, use the data annotation validation attributes, or implement the iValidatable object for formal validation. And most importantly, do not perform domain validation. DDOs transfer between the presentation layer and the application layer. So do not try anything related to the domain right here. Do not, for example, try to check the unique username constraints right here in the DDO. As for the output DDO best practices, try to keep the count of the output DDO as minimum as possible, and reuse it whenever possible. And that's the complete opposite of the input DDO, since we were trying to make as many input DDOs as possible. Do not reuse input DDOs as output DDOs. Output DDOs can contain more properties than used in the client code. Return entity DDOs from the create and update methods. Now let's get back to our module and check out the DDOs that we've created. First of all, let's get back to our domain layer and check out the aggregate root that we've created, which is the customer class right here. If you see, we've got the name, the surname, the customer group ID, the contact information, and the address, which is the value object. And we're going to be creating DDOs according to these. Let's check out our application contracts layer. We've got our customers folder right here. And the first DDO is for the address DDO. As you can see right here, here is the value object. We've got the country, city, town, line 1 and line 2, right? Same as right here, country, city, town, line 1 and line 2. This is against our best practices if we're using this for both input and output. However, we're doing something like this only with the address DDO and the contact information create and update DDO. As you know, in our best practices, we should have a DDO for create and we should have another DDO for update. But we're only doing this with the sub-entities that are inside our aggregate root. As for the aggregate root, we did apply the best practices for it. We're just trying to make as many scenarios as possible. So that was the first DDO, which is the address DDO, that has the exact same properties as the address value object. And it does derive the entity DDO that we've talked about. The next DDO, which is the contact information create and update DDO, does have the same thing. It's going to be used whenever we create or update a contact information. And the properties are the name of the contact information, the type of it, and the value, of course. And as we said, it has some simple validation since it's an input DDO. And this right here has the same idea as the address DDO, the contact information DDO. It also derives the entity DDO, and it does have the exact properties of the contact information. We can take a look right here. As you can see, we've got the name, the type, and the value. The only things that we need for the contact information. For the next DDO, we've created an abstract class for our aggregate root, which is the customer. So we've created a customer create or update DDO based class. It is an abstract class which is extensible and it's going to be derived by the customer create DDO class and the customer update DDO class. It has the properties of the name, surname, customer group code, contact information, and the address. And right here in these classes, we can specify the create properties and the update properties, each for its own. after we derive the abstract class. It is still the best practice to separate between the create and the update DDOs, but we're trying to showcase as many scenarios as possible. The customer DDO class is only going to have the name and the surname, and it's going to derive the entity DDO with the primary key. However, when we call the customer with details DDO, it's going to derive the extensible entity DDO with the primary key, and it's going to have the name, surname, customer group code, contact information, and address. The customer group create update DDO is going to derive the extensible entity DDO with the code and the description as properties, and it's going to have some validation. Whereas the normal customer group DDO is going to derive the extensible entity DDO with the primary key, and it's going to have the code and the description as properties. And last but not least, the get customer list DDO, which is deriving the paged and sorted result request DDO, and it's only going to have the filter as the only property. And we're going to see how we're going to use these DDOs in the next video. Please refer back to the documentation for the extra details that we haven't covered in the video. This has been the DDOs with the ABP Framework. See you next time.